I think my first mathematical shockwave was way after I was a child. I was more like 15 or something like that. So, when I was a child, I just remember learning multiplication tables and doing the usual problems at school, and even I remember at some point in around 12 years old when they started to introduce some new concepts. I had to struggle a little bit at the beginning to understand them, and maybe because they had not been very well explained, and then it was fine. But I think I really came to mathematics on the later side. Like, it's not a sort of childhood passion of mine, and maybe I don't know. I think the women mathematicians that I know seem to share this experience. Maybe I'm not sure for all of them, but certainly the ones I've talked to. So I don't think that you have to be a sort of a child prodigy or have a passion for solving puzzles as a child, or even a passion for chess or something similar to become a mathematician. I think there's many ways to get to mathematics and to be attracted to them, and it's not necessarily this sort of stereotypical way that people imagine. So in my case, I think it was really more as a sort of intellectual discovery when I was in the end of high school. And I remember the first definite moment where I was where something happened, which was when the teacher had given some homework problem to solve, and I remember having had to struggle to find the solution, and I had to think about it for a long time at home, and the question was like floating in my mind, and I thought, and at the end I came up with a solution which was quite convoluted and maybe creative in a sense for that age. And I remember having felt very satisfied with the process of, thinking about something for a long time and then finally figuring out an original solution that I didn't think I could find. And then I remember also presenting my solution to the teacher in class, and she was very sort of shocked and surprised because I think that was not the expected solution, and I had found some sort of inequality, some sort of functional inequality, I think, without realizing. But I remember this was a sort of clicking moment where I thought, I really like actually solving hard problems. Like when the problem becomes difficult, that's when I start to enjoy it. And this was my first encounter with that, and with the process of searching and thinking about something for a long time. And I think that's when I decided, I think I want to try to be a researcher in mathematics. So I think there was this moment that I mentioned, and then I came up on my own with this idea that I would like to try to do research. On the one hand, I was very attracted to the idea of research because it was a sort of very romantic or idealistic view that this would be a nice job, a nice profession to have. And then my idea of research came together with my taste for mathematics, and it seemed, so I should do research in mathematics since that's what I like, that's the subject that I like best, and that's the sort of occupation that attracts me the most. And I had this sort of dream, but I was a bit alone with it. I didn't have mathematicians in my surroundings. I didn't talk to my teachers about it. I sort of kept it to myself. And I think the teacher I had the following year, the last year of high school, was a very excellent and inspiring maths teacher. And so that sort of helped me, confirm me in this desire to at least want to pursue studies in mathematics. And then the teacher I had the year after, which is the first year of the equivalent of university in France, classe préparatoire, was really, I think, very influential intellectually. He really presented beautiful, mathematics where you sort of start from almost the beginning and you get to all the fundamentals of what a mathematician should know at that level. And it was a very dense intellectual experience. We learned a lot of mathematics in 1 year, and he was a very also a very inspiring teacher, and I think he had a very pleasant personality, and he played a big role in encouraging me, I think, telling me that I could do it. When I started to tell him about my project to really try to get into an ENS, an École Normale Supérieure, which is the place where you train for research in France, and the best place to train for research, maybe. I had mentioned it to him as a sort of far-fetched dream that seemed quite difficult to achieve, and he told me, no, I think you can do it. You have to, you have to try, and I think you have the capacities and stuff. And I think that, of course, played a big role in giving me some confidence, that this was possible. And so the personal relationship combined with the way that I really liked his teaching, the way he presented things, I think played a big influence on my desire to continue. And I have not, I don't think I have had somebody so maybe so influential, so that determined so much for me since then. And it was also a very sad story because he died a few years later. He died of AIDS. He was like almost like the last generation of people who died. Like a couple of years later, the treatments were strong enough to basically keep people alive. So it was also a sort of shock for me because the moment that I got admitted to the École Normale Supérieure where this happened, just a few months later, he passed away. So I think after I arrived in ENS, then certainly a lot of people had influence on me. We had a set of professors who were teaching us courses who were all very interesting and who played a role in helping us decide on our precise orientation topics. It was a very stimulating atmosphere, very protected in a way because you knew you were in good hands in terms of advice, and so certainly I remember somebody like Patrick Gérard playing a big role, and then later Chaim Brezis when I started my PhD was very encouraging. So Bernard Elfer, Yann Brognier, so a lot of sort of people welcoming you into their community and making you feel that they want you to be a part of it, and even though you're still a young person with no achievement yet, that you were on the right path to becoming a full member. So that was, of course, very lucky to be in this environment. No, there was no. Okay, I had one uncle who was a researcher in CNRS in biology. So that's what I knew of research. Is that there was. I knew there was such a thing called CNRS, and I knew that my uncle was working very hard in a lab and going there on weekends and stuff like that. So that was something, and so I had this sort of dream that the CNRS could be the place for me to work in, but I didn't have mathematicians per se in my surroundings, but definitely. Yeah, my mother is a teacher, and so she had a lot of experience with seeing kids and students and what they become later, and so she played certainly a big role in telling me that I could do whatever I want and whatever I wanted, and that I had the potential, and that if she compared me with all the cohorts of students she had seen, I was definitely, among the better ones, and so I should believe in my potential. Certainly that was important, it was very useful. So I work on what's called originally partial differential equations and mathematical physics. So I was trained as an analyst, as somebody who studies equations and the minimization of energies and things like that. And I did my PhD on the Ginzburg-Landau model, which is a model for superconductivity. So it comes from physics. And so I've always been interested in studying problems that come from physics, but from the point of view of a mathematician. So developing mathematical tools to understand these problems and to be able to predict what should go on in the physical system. So this is my specialty, and it has evolved over the years. I worked in fact for many years on this same equation, this same model of superconductivity. There's a lot to say about it, and then this led me naturally to branch out towards some related models of systems of interacting points, which arise in statistical mechanics. So it's again physics, but it's a slightly different topic. And all of these are in fact related. And what's beautiful is when you do mathematics, you discover that as you progress in your career, that in fact everything is connected. And so you start from a very, very narrow entry point, and your spectrum and your point of view broadens and broadens, and you have this satisfaction of feeling that you understand a bit more and a bit more as years pass, even though the field of things to understand is even much bigger. But at your own personal scale, you keep broadening, and that is very satisfactory. I don't think there are many jobs which bring you this this feeling. Okay, so I think I described the first one that happened to me in high school, clearly. And then during my research, when I started to do research during my PhD, I clearly remember the first two sort of mini breakthroughs that I made with myself. And interestingly, I was thinking about it, they both happened as I was in bed. So I had been, of course, thinking about my problem for days and weeks and doing computations, and then, you compute, you think, you compute, you don't really get anywhere. And then the next day, when you're in bed, you relax, you just let your ideas float, right? It's the same, at the same time, the same that would happen if you're trying to fall asleep or waking up in the morning. You're thinking back of the day, and then that's the moment where all your thoughts about your problem come back, and in fact they recombine in a different way, and then suddenly I saw, but with this computation I can actually do this. It's like it's a very nice feeling. It's like looking at a picture which is blurry, and then so you don't quite see, you're not quite sure what you're seeing, and then suddenly it becomes in focus. And you see what there is. And once you've seen it, you know it. Like there's no. It's really a bit like that. So I remember these first two moments where I found some like good quantity to look at and some idea of something to prove, etc. And then since then, of course, I've had others, but maybe they are less memorable because they are not the first ones. So the first moment was when I realized that what I had done to prove existence of solutions that have to study minimizers of the Ginzburg-Landau energy and describe their vortices and how many vortices they had, I suddenly realized that I could tweak the idea, twist it a little bit to prove the existence of stable solutions with arbitrary numbers of vortices. So I could prove that for any number n, I could find actually a solution that would be stable and that would have n vortices. And I could do that by a sort of local minimization procedure using the quantization of the energy. So it was, in fact, it was something that happens commonly is you realize that what you've done contains more than what you had seen up to now. Like you haven't exploited the full potential of what you've started to do. The second one was something was about a year or two later. It was I was working on some models from micromagnetics, and with my collaborator Tristan Rivière, we had been doing computations with like certain quantities. Like he had told me, I think I can try to prove some local conservation laws on certain quantities. And then it appeared to me that day that, this is the right quantity, and this is the identity we can prove on it. So it was a really algebraic discovery, and that really unlocked the problem for us. So we discovered an entropy, like something that you can explicitly relate to the energy and has good properties. And so it was very, very nice at that stage where I was, very young too. It seemed like a big step for me. No, the first one, it was work I was doing alone, so I had no one to share it with, really. So I was sharing it with myself, but I remember having felt very excited. And then the first thing you want to do is you want to go and write and check that you're not mistaken, that if you actually put down the details, it's still holding, because sometimes you have an idea in your mind, and when you try to write it, you realize there's a flaw, you missed something. So I remember this sort of excitement and impatience, and this is the kind of things that can actually prevent you from sleeping. So if it happens in the evening before you actually fall asleep, you can lose your sleep over it because you're too excited that you think you really found something. So fortunately, it doesn't happen every day. So most of the nights you can sleep. But and then when it's work in collaboration, of course, you want to call your collaborator and say, "Hey, I found something." So I think the first moment that I had a chance, I called my collaborator to tell him. And yes, you definitely want to. It's very hard to keep something like that to yourself. You definitely want to tell somebody about it, even if it has to be someone who doesn't understand math at all. But at least you tell them, "I think I found something today." I think the beauty of mathematics is that things seem to be in sort of harmony. You don't understand exactly why and how, but the things that are true and feel beautiful. And we develop a sort of intuition as mathematicians of things that feel true and don't feel true, and sometimes we even call them moral. We say, this is moral, this is not moral. Because we are guided by a certain intuition which is based on our experience of what a true statement looks like. And these true statements, they very often have a very beautiful sort of symmetry and harmony. And so it's difficult to describe without getting into specifics. But certainly there is this impression that, as I said, everything is related, and the correspondences between objects and between quantities are really something beautiful when you discover them and when you understand them. It's as if, there's always this debate over whether mathematicians are inventing concepts or whether they are discovering truths that are already there somewhere in nature, right? and I think that it seems that the reasonable thing to think is that this is all a creation of our minds, but we cannot help but feel that this is all there, and we're just uncovering these beautiful objects and concepts, and the connections between them. That's what is most aesthetically pleasing. I think that there are now many ways to read about mathematics. There are people that have done a great job at writing popularizing mathematics in books for a broad audience and in movies, and there's lots of resources on the internet. So I think it's possible to certainly hear and read about it. It's hard for me to imagine really what it is for a person who has no training in mathematics when you read such things, because I see them. I'm a mathematician, I cannot forget that, right? So I understand a certain amount of the concepts that are needed there. But I think that people seem to find some pleasure in even hearing about it, like a sort of music that you don't necessarily completely understand, but that is nice to your ears, right? Like someone who has never studied music can still appreciate music. So I think it seems to be a rewarding experience. And of course, there are the museums, right? The Palais de la Découverte and special exhibitions that have been organized. I think in a way, mathematics is, and maybe science in general, but particularly mathematics, is not in its approach, in the approach of mathematicians, it's not completely distant from art in a way, like from at least a certain form of, again, you find the same notions of creativity, aesthetics, but also work, right? You have to work hard to get there, and searching for a certain clear image, as I was describing, right? The moment when things get in focus, and I'm sure that that artists also have these moments where suddenly things come together and crystallize into the final thing they want to say. So so this is one aspect of mathematics. Of course, the other aspect is that mathematics is useful. It's not just for the pleasure of beauty. We do it also for that, but we do it because it helps to understand the world, and then it has an effect on the world in the long run, because it influences how we can compute things and how we can engineer them, and technology, etc. So mathematics really irrigates also society in that sense. But I think both aspects have to be kept together, kept alive. Yeah.